So that is we have already seen that problem. Again we are going to see about the another problem, that is for a FIR linear phase digital filters. So A34 values are given. So here is one of the home problem, that is design a filter with HD of e power j omega, and that value is given using the Hamming window and Hamming windows with n is equal to 7. So if it n is equal to 7 is given, means we have to find out the Hamming window formulas and also substitute the Hamming window formula, and then we have to get the HD of n value, HDM of HD of n. Okay, so we have to multiply together and get the tabular column. Next, for a FIR linear phase digital filter approximating the ideal frequency response, the HD of e power j omega is equal to 1, modulus of omega is less than or equal to pi by 6, 0, pi by 6 less than or equal to omega less than or equal to pi. So that is the HD of e power j omega is equal to given value. First step is to find out the filter coefficient. So that is HD of n, that is equal to 1 by 2 pi integral minus pi to pi h of e power j omega into e power j omega n into d omega. Okay, so that is 1 by 2 pi here, integral minus pi by 2 to pi by 2, 1 into e power j omega into d omega. So sin n minus alpha into omega c divided by pi into n minus alpha. So that is alpha is equal to 0. So HD of n is equal to sin pi by 6 n divided by pi minus 2 less than or equal to n less than or equal to 2. So for n is equal to 0, HD of 0 is equal to sin pi by 6 into 0 by pi by 0. So we will get the answer as 0.16. So likewise we have to find out for n equal to 1 and then n equal to 2. Okay. So next is the second step is to using the rectangular window formula. So WR of n is equal to 1 for a m minus 1 by 2 less than or equal to n less than or equal to m minus 1 by 2. 0 for otherwise. 1 for a minus 2 less than or equal to n less than or equal to 2. So WR of 0 is equal to WR of 1 is equal to WR of 2 is equal to 1. Next is step 3. So the step 3 we have to find out the filter coefficient using the rectangular windows. So for that we have to use the formula as h of n is equal to HD of n into WHN of n, WR of n. So that is for minus 2 less than or equal to n less than or equal to 2 limit. So h of 0 we have to find out, h of 1 we have to find out, and h of 2 we have to find out. For that we already know the HD of n value and also WR of n value. So we multiply together and we will get the answer of h of n value. Okay. Step 4. That is we have to find out the transfer function of the filter. So that is h of z is equal to h of 0 plus summation n equal to 1 to m minus 1 by 2 h of n z power n plus z power minus n. So for that we have to substitute the values, that is 0.5 plus summation n equal to 1 to 2 h of n z power n plus z power minus n. So we will get the final answer. So the step 5 is transfer function of the realizable filter. That is h dash of z is equal to z power minus m minus 1 by 2 h of z. So that is z power minus 2 into multiply the above h of z value. So we will get the h dash of z answer. So the filter coefficients of the casual filters are given by h of 0 is equal to h of 4 is equal to this value. So that is h of e power j is equal to summation n equal to 0 to m minus 1 by 2 a of n cos omega n. So then we have to find out a of 0, a of 1, a of 2. Then I have to substitute the values in the tabular column. Okay. So the next problem is design an ideal bandpass filter with a frequency response. Find the values of h of n for n is equal to 11 using the rectangular windows. By using rectangular windows we have to find out the answers. So that is hd of e power j omega is equal to 1 pi by 4 less than or equal to omega less than or equal to 3 pi by 4. So 0 otherwise. So for this omega c1 is pi by 4 nt and omega c2 is 3 pi by 4. So first step we have to find out the filter coefficients. So there is hd of n is equal to 1 by pi into n minus alpha sin omega c2 n minus alpha minus sin omega c1 into n minus alpha for n is not equal to a. So that is 1 by pi into n minus alpha sin omega c2 n minus alpha minus sin omega c1 into n minus alpha for n is not equal to a. So when we are substituting the value, we will get the 1 by pi sin 3 pi by 4 minus sin pi by 4. So for if n is equal to 0 means hd of 0 is equal to 0.5. If n equal to 1 means we will get the answer 0. N equal to 2 we will get the answer minus 0.3183. N equal to 3 means 0. N equal to 4 means 0. N equal to 5 also we will get the answer as 0. Okay. So next step 2, we have to find out the using the rectangular window, we have to find out the answer. So there is WR of n is equal to 1 for m modulus m minus 1 by 2 is less than or equal to modulus m minus 1 by 2 minus 0 otherwise. So that is equal to 1 for a minus 2 less than or equal to n less than or equal to 2. So WR of 0 etc. equal to 1. Up to 5 we have to find out the answers. So step 3 is the filter coefficient using the rectangular. So h of n is equal to WR of n into hd of n. So we have to multiply both together. So for that we have to find out hd of 0, h of 0, h of 1, h of 2, h of 3, h of 4, h of 5 values. Next step 4 is that the transfer function of the filter which is h of z, that is equal to h of 0 plus summation n equal to 1 to m minus 1 by 2 h of n z power minus n plus z power n. So the step 5 is transfer function of the realizable filter is h dash of z. So that is equal to z power minus 5 into this values. So the filter coefficient of the casual filters are h of 0 is equal to h etc. equal to 0. So h of e power j omega is equal to summation n equal to 0 to m minus 1 by 2 a of n cos omega n. So that is a of 0 etc. Will get the answer. So find out the values, that is a of 1, a of 2, a of 3, a of 4, a of 5. So that is h of e power j omega is equal to this value. So in the tabular column we have to substitute the values, that is h of e power j omega and also modulus h of e power j omega in the decibel values. So for that each and every omega in degrees we have to substitute the answers. The next question is given that values. So for that we have to find out the rectangular windows. So that is the limit has been given to pi by 3 to 2 pi by 3. Okay. So omega c1 is pi by 3 and omega c2 is 2 pi by 3. So first step then is filter coefficients are hd of n is equal to 1 by pi into n minus alpha sin omega c1 into n minus alpha minus sin omega c2 into n minus alpha plus sin n alpha into pi. So that is 1 by pi into sin pi by 3 minus sin 2 pi by 3 plus sin n pi. So if for n equal to 0 means we have to first substitute the values in this hd of n. So there is hd of 0 one value will get. Likewise we have to substitute hd of 1, hd of 2, hd of 3 and then hd of 4 and hd of 5. So hd of 1 is 0, hd of 2 is 0.2757, hd of 3 is also 0, hd of 4 is minus 0.1378, hd of 5 is 0. So step 2 we have to find out using the rectangular window. So for that the equation is, that is WR of n is equal to 1 for minus modulus of m minus 1 by 2 less than or equal to n less than or equal to m minus 1 by 2, 0 for otherwise. So 1 for minus 2 less than or equal to n less than or equal to 2. So that is WR of 0, WR of 1 equal to WR of 2 equal to WR of 3, WR of 4, WR of 5 is equal to 1. So the step 3 is filter coefficients which is using the rectangular window. So that is h of n, h of 0, WR of n into hd of n. So that is we have to take the limit from minus 5 to plus 5. So that is h of 0 we have to first find out, h of 1, h of 2, h of 3, h of 4 and h of 5. So next step 4 is that the transfer function of the filter is h of z, that is equal to h of 0 plus summation n equal to 1 to m minus 1 by 2 h of n z power minus n plus z power n. So that we will get the answers. Next step 5. So there is the transfer function of the realizable filter is h dash of z is equal to z power minus 5 into h of z. So we multiply with z power minus 5, then we will get the h dash of z equation. So the filter coefficients of the casual filters are h of 0, h of 1, h of 2, h of 3, h of 5. All the values we have already get, so that value we have to equate it and finalize it. Then h of e power j omega is equal to summation n equal to 0 to m minus 1 by 2 a of n cos omega n. So that is a of 0 is equal to h of m minus 1 by 2. So we will get the answers. Next is a of 1, a of 2, a of 3, a of 4, a of 5. Okay, there is a h of e power j omega and modulus h of e power j omega in decibel value. We will get the answers. This is another question, that is a high pass filter with using a window. So the cutoff frequency has been given and n is equal to 9 is given. So there is ohm c is equal to given, t equal to once again, and omega c is equal to tc is equal to 1.2 radians.